Welcome to Managing Development and Pre-Production Database Environments in a DevOps World. My name is Kendra Little, and I am a DevOps advocate at Redgate Software. What that means is that I get to spend a lot of time thinking about and working with folks to optimize the practices, tooling, and the ways they work together as a team to write changes for databases, test them thoroughly, and deliver them quickly and accurately to deliver value to their customers more quickly. What we're going to talk about today is about how do we build out these development and pre-production databases, and how do we maintain them? And I'm going to talk about first this legacy approach. A lot of folks are still using this legacy approach. And when I first started out working with databases, I started working at a small startup that used this legacy approach. What we did at that startup was we, over time, started adapting agile development methodologies across all of our teams. So for both applications and for databases, we started looking at how can we do this better? And when it came to databases, some things were really, really hard. So I'm then going to talk about what are those pain points? Why and how does this legacy approach fall down? And then we'll talk about what a DevOps approach to this looks like and what technology and tooling, as well as just a lot of learning about what works well and what doesn't work well over the last years, have enabled when it comes to modernizing this approach. And then we'll pull this together with some recommendations on how, if you want to modernize your approach, how to start with that and make sure that it is successful and meets the needs for your team, because you don't want to modernize where it isn't needed. So we're going to talk a lot about why this is needed and how to identify what you can make better and the benefits that will have, right? Because you have to have reasons that you would modernize. All right, so first up, let's talk about this legacy or classic approach to development and pre-production databases. Here's what the classic approach to this often looks like. We have multiple developers who are accessing a shared development database. Now, it doesn't have the label dev, it's the one that just has all the people around it there on the left. What we've got is developers who are making changes in a development database, and then periodically, those changes are moved into perhaps a QA environment. Here we just have one QA environment. In reality, when this is in place, sometimes things go to a QA environment and then they go to another environment before they ever go to staging, which is also known as pre-production. And then finally, they go to production. And in this most classic way, people are all sort of this shared development database there's a lot of issues and things that can go wrong with this. If one of these developers is working on the same bit of programmable objects, say working on the same stored procedure that another developer is working on, well, they may script out that object at different times. And in a database like SQL Server, when you're working on something like a stored procedure, when you even if you have create or alter, you're always replacing the entire body of the procedure. So it's really easy, in other words, for one of these developers to work on an object that someone else scripted out a few minutes ago, right? I go ahead and make my change to the object, and then Jane, who's sitting next to me, she's like, oh, okay, I finally got this like I want. She makes a change to the object, and she just overwrites what I did. Right? So we have to either email or chat with one another or do some coordination to make sure that either we're using some way of locking these objects or that we aren't overwriting each other's work. Also, things can get weird when it comes to making sure that the changes are ready to go. It's really easy for me. I'm just like everyone else. I always try to protect myself against my own mistakes because it's really easy for me to make a change to the database to test something out, but then when it's not where I want to go, maybe I changed around a table and I added a column because I thought I was going to do something in a particular way, but then I think better of it. I'm going to do it another way, but maybe I forget to clean up that column I added if I'm not going to use it anymore. if we're just passing changes from this shared development database onto another database, how do we know what little tests we just made in this development database and if they were all cleaned up properly by everyone, as they were just working out what is the right thing to do, right? Because to test anything out, I have to make the change to the database and then I have to keep track of what I did so I can undo it. It's just, there's so much room for error in here. Now, in this legacy layout, some people modernize this a little bit. And this is where we actually started out when I started out at that little .com years ago. Our teams were using shared development databases, and each team kind of had their own shared development database. They weren't all using one because there's different parts of the system. So for each production database, there's a shared development database. And they were using source control. So here I have version control system in there. So changes would be made to the shared development database, and then when it looks like, okay, this looks like what we want to ship, changes would be reviewed and put into version control, and then the scripts that had been put into version control would then be deployed to QA and staging environments and above. Now, this can improve on some of the flaws that I talked about before, because at the point where we're putting things into version control, we can try to work around some of those problems that I mentioned. We can try to make sure, hey, did I overwrite Jane's changes? Right? Did Jane overwrite my changes? We have something we can review that's not just a database, but of course we have to take the time to do it. We have to actually identify that. And then also we have to take the time to see, okay, are things getting scripted out and put into version control, which are, those just things we were trying out that we don't want to get farther. So we kind of have a place to review these things, but it's awfully tricky, and it's often kind of a manual step. It's depending on what tooling you're using here. If you're using a lot of automation, you might get things into version control that you don't want in there, right? Because now you're not carefully reviewing because you've maybe introduced automation to kind of do some of that for you. So it helps a little bit, but it doesn't erase the pain points a ton to just introduce version control into this. And I really think the pain points with this model, there's a wonderful post written by Troy Hunt, and he wrote this post like 10 years ago. He wrote this post a while back. This isn't a super fresh point. It's all about the unnecessary evil of shared development databases. And if you check out his post, he has a lot of things of just why using a shared development database doesn't work. We've talked a little bit about the last writer wins problem. I think one of the biggest deals with this to me is that it limits innovation and it limits creativity. If we are using a shared development database, if changes I make in there maybe impact you, maybe slow you down if you're on my team, I'm going to be more hesitant about just doing wacky things and testing different things out. Because the more I test things out, like, oh, what happens if the data is different in this table and this happens? Well, that could impact you if you're testing anything using that table, right? I'm going to be much more hesitant to do that. In addition, this notion of the shared development database doesn't work well with modern systems like Git, which are very popular for version control. And by this, I mean you want, like with a distributed system like Git, my pronunciation's suspect. You want people to be able to do things like check out their own branch of code to use for feature development and to be able to work on it and to apply it to a database and validate it in a way that that database can reflect what is this branch like, whereas other people can be working in another copy of the database that maybe shows, hey, this is what the master branch is like. It doesn't make sense when you're working in a system that encourages branching to have a single database that's trying to represent, here's what this branch is like for this user, but how could that also represent, here's what the master branch is like, or here's what this other branch is like that's in use by another user. It makes much more sense to have a more flexible model where at any time you can say, I am going to apply the code in this branch, whatever type of branching system you're using, to this database, and it will be current with that. And I can then apply your branch to my database, see what you're working on, see everything in the context of that. So there's many more points in Troy's post, but it points to the fact that what we really need when it comes to managing these databases is a DevOps approach. And here's an example of what a DevOps approach can look like instead of that pipeline. In this diagram, every single developer has their own copy of the development database. And notice that these databases are using a little bit of magic, denoted by the stars here. And the idea is that we're bringing in an infrastructure as code idea to this. It's really database as code here, so that all of us, when we're working on something, can work not only in an isolated branch in version control, but we have our own copy of the development database that we can apply that source code to. And that enables us to create our changes in isolation, but using version control to share them, so that we can do things like when I want to review on my code, I can push my branch, if I'm working in a feature branch, to the centralized Git repo. And I can do a pull request and say, hey, can you take a look at my code? I can use automation to say, when I create a pull request, I want the automation to kick in to build a fresh copy of the database and to apply the code from my branch to it, so that the people who I'm saying, hey, can you take a look at my code, they aren't just stuck looking at SQL statements. They actually have an updated copy of the database that they can work with, that they can run queries against, and that reflects that code, so they can actually properly interact with a little bit instead of just kind of like, what does that do what I think it is? They can even have that automation do things like build the application related to my branch of code along with the database, so they can even interact with the application and do a much, much richer review than otherwise. Similarly, after code is reviewed and approved and merged in, just like we would do with application code, using review processes to control the flow of changes into centralized branches, when we're ready to do a release, we can automatically create an environment for QA and apply the changes to it as well, and so on. Now, one interesting thing in this diagram, which is a bit controversial, is that note that I don't have any stars around the staging database. Some folks watching this may be like, you need to take this even farther, Kendra. You should be dynamically creating every environment up to production. And the reason that a lot of folks, I think this is something that you can consider doing, but right now, for many environments, especially if they're more legacy monolith environments, right? For something like a microservices environment, I would argue that you can dynamically create every environment and automate testing up through production, even for the databases. But for environments that have more dependencies between the data store and other data stores, it is still quite common to need a more static staging environment that is configured as closely to production as possible. And that's because we haven't reached the full point of infrastructure as code for most of us when it comes to deploying to production. And we still have environments that are complex enough, that have things like transactional replication or cross-database queries or cross-database dependencies, so that we do want to have a more permanent staging environment that's quite similar to production, so that we can ensure that, hey, if the processes we're using and the tools we're using to deploy to production, we are testing those as closely as we can before we deploy to production in this staging / pre-production environment. So I do think that if the goal here, and that many as active applications evolve, as designs evolve, we're going to get more and more to having all ephemeral environments before we get, to production. But here we do still have a staging environment in this diagram that isn't ephemeral. And that, I think, even in a DevOps pattern for this today, I think that for many of us, that is still going to be the case there. So if you're looking at where does this model fit, this is really for folks that are in active development, right? If you have a legacy system that isn't under active development, you're not using the development environments very often. You may even have them on virtual machines that you turn off for long periods of time when they're not in use, right? Modernizing, taking the effort to modernize is more going to be in an area of active development, and this is going to be most attractive to teams who are already using Agile and DevOps methods in their application code and in their application processes, who are ready to extend this to the development environments. The reason that this becomes attractive to them is that often if you have applied, in fact, almost always, if you have applied Agile and DevOps methodologies to the application and you've done well with that, you get to a point where things can go fast, but then as soon as you need to make changes to the database, things slow down. Right? So you have this bottleneck, you have this two-speed culture where we can reliably do changes well for the application layer, but when it comes to database changes, either we go fast but we're prone to error, which isn't really going fast, or it's just really slow and cumbersome. So if you have leadership who says, we want to get better and better at delivering value to our customers more quickly, and this is your bottleneck, then this is a natural area to invest in. You, of course, in order to make this happen, you do want to have good storage and network in place or be willing to have that, because in order to do something like these ephemeral databases, you don't want to do this on a stack of old rotational hard drives. It's just going to hurt. So some of the things that folks say sometimes are, but Kendra, we can't do this because realistically, our production databases are 2 terabytes. We can't give every developer a 2 terabyte database. Consider thinking about either technology that can help you do that or establishing a minimum viable data set for this. Also think about being able to enable this even if developers have low permissions. So thinking about, okay, if we're using a data set that doesn't have, we only want to use data sets that are safe, that don't have personal information in this. Can we give more permissions to developers to have these data sets if we can certify they're safe, even if they have low permissions? This creation of ephemeral databases will often need collaboration from the operations team. If there are concerns about this, bring those folks into the discussions on the automation and see if they're willing to approve certain workflows for the management of these data sets and the creation of them by automation, even if they're not willing to give everyone sysadmin permissions on existing developer instances. You will have to fight against sometimes that we've always done it this way mentality. Looking at ways this can enable you to test better as well as to go faster, not just talking about going faster, but talking about building quality into it, which this really, really enables by allowing those more advanced review processes I talk about early on, those code quality processes that can help show people why the change is worthwhile and what it will enable. So finally, bringing this all together, if you want to modernize your approach, start with looking at your current pain points. What goes slow? What databases are a problem to update, either because it's really, really slow to work with them or because errors keep being made when you go fast. And narrow down an opportunity that you're looking at where modernizing this approach you think would be of a big benefit to your organization. Talk to the folks who work in that area and see if you have stakeholders who you can get on board for working in a proof of concept. POCs or proof of concepts are increasingly popular as a way to prove out a concept. Not saying, hey, we're going to do this everywhere. We're going to reinvent everything. But we are going to try out an option that has self-service and automation in a safe way using either a minimum viable data set or a cleansed data set where personal data has been de-identified in order to help us write code faster. Now, if you are using a minimum viable data set, that doesn't have to be in every environment. Your staging environment can still hold a full data set. You can still do full performance testing there. But if you've got a 2 terabyte production database, you don't have to use 2 terabytes in every single environment you use. But you do want to use safe data in every environment you use. Thank you so much for joining me today. I'm Kendra Little, and I hope to see you in another session soon.